So this is where we are today. Genesis of a Future is the title of tonight, and I want to talk to you guys about design through dialogue with data. Yeah, that's what are we gonna do tonight. And for those of you who know me, I'm still your Dong Hao. I didn't change. And for those of you who don't know me, my name is Nguyen Dong Hao. Yeah, and I am a master graduate from Dessau International Architecture from Anhalt University of Applied Science, which is located right next to our famous Bauhaus building. And we are actually collaborating with them. I mean, our university collaborate with Bauhaus Foundation as a academy. And that's where I graduated. And the city is right in the middle of Germany. Okay, and why are we having this talk tonight? Of course, I want to make you understand the way it looked like to generate design with data. Yeah, so don't worry about that. I won't ask you to generate any design. I will do that, and I did that already. And this is just to make you understand it. If you don't, please raise your hand and your questions in the end, and let us see how this mission may be possible. Yeah. Okay. So to generate design with data is, in a simple word, the logic of generative design. And please don't confuse this term with Autodesk software. They have a software named exactly generative design. I'm not talking about that. And I'm talking about generative design in a design philosophy way. And what are we having nowadays, as A.R. Samuel have told us? Nowadays, a lot of us, we draw in the office or our desk, and design with this, what I would call additive logic. Yeah. What is additive logic? So it is basically data stacking on top of another data, layers and layers of data. So a good example of them will be that how we use butter papers. All my fellows architecture students and peers and colleagues, we all know how the things was designed. We layer things on top of each other. And even if we print out before submission, we still do that, layers and layers of information on top of each other. And what happens is that through this kind of way of design, we always get this. I guess this is a very similar, familiar scene with a lot of you. Of course, in the end of the day, we are talking. Wait, can you actually see my cursor? I can point. Oh yeah, cool. I can have this. All right. So of course, we always ended up with this kind of situation. With a lot of things that we wish are final, but they actually not for numbers of reasons. And when the things came out in the end that we call final, we've totally lost touch with all those previous motive or motivation or whatever you're going to call it that we started with, and we ended up in this kind of situation. So where is the logic, when we design like that? Of course, once in a while we have nice words coming out, but those nice words are actually the snapshot of a certain very arbitrary decision, or to the subjective of a certain participants in the project, and so on and so forth. So what is the logic of generative design, and how is it going to help us in this way? So in a very simple and a figurative way, associative design is different with additive design, additive logic, in a way that the way data are managed. Yeah. So instead of stacking data on top of each other, we actually let the data float free within our frame of logic. Now you have to use a bit of your imagination here. So we actually let the data flow within that realm, and we try our best to establish the relationship between them. And so by doing so, those data actually manipulate the output. And when data change, the relationship don't change. Of course, you can also modify the relationship, but to design with data, that means we put the data as the main role. So we expect them to change. We expect the world to change, as the change is the constant of the world. Yeah. So data will change, but we keep the relationship. And what are these relationships? These relationships are, our ideas on concept and betweens. So we keep them. So I will show you a couple of examples. So this was a very famous polygon. Of course, I made this when I was with Professor Dieter Rappler. He was a four-course Lehrer. That means like an admission programs teacher in Bauhaus University. But when the Bauhaus University was shifted to Weimar, he came to our university, Anhalt University of Applied Science, to teach. So this was one of the works I did with him. So in this image, you can see that these are a group of surfaces that's triangle and rectangle, and they are kind of located next to each other for a certain reason. And you see the reason on the next step. When you fold them, you will reach to a polygon. But even though in the end of the day, it is a 3D polygon, you could turn it back to 2D because of the relationship between them. Yeah. So this is just a very simple example that I want to give you about this associative logic, about this network. And this is not a new thing. In fact, there are a lot of pioneers in this, and it was made popular when the CAD program became available to us. But that was not the starting point of it, because associative logics you could trace back to Antonio Gaudi actually. But for the sake of our context here, we speak about the time when the CAD was invented, during 1960s. And the pioneers like Peter Eisenman, he made his design of this famous house. I don't know if any of you recognize this. By right, you guys should, because this is one of the classic in architecture history. So what is the special thing about this house? Look at it, it's just a box and with a bunch of planes on it. What is so special about it? The special thing about it is that it opens a new era of thinking for architects. So this was how the final outcome came to be. It's through a series of iteration. The key words here is the iteration. That means by generation and generation of modifying slightest bit of parameters in the form of data, and it gives you a lot and generates you a lot of different variation of designs. And this axis here is not the only axis here that matters. If you look at this y-axis here, it is another parameters of this initial box that came to be, So you have this kind of structure frame, and he talks about the plane, which is the openings and the walls within the buildings. And the first row here is about the solids, So in between them, he actually associates each of them and each parameters with different kind of iterations to check as a designer. Now, as a designer, you don't keep going back to your drawing board, You of course have, draft person to do it, but what you should be presented are options of design that could be potentially optimized for a solution to your client and to an environment in our context nowadays. Yeah. So these are just some example of associative logics, how data relate to each other. in a direct way and an indirect way. So next, I will tell you like a little bit about, a little more hands-on. Yeah, I did the hands-on part, of course, because I realized when I pull that sliders and all that stuff in in front of the computer, now it will take too much time and it makes the talk become very boring. So I decided to run around for you. So now let's say I give you guys a mission to reproduce this image. So in a traditional way, of course, if we were to reproduce this, maybe we could go to a painting where we add layers and layers of shades and tones on top of each other. Yeah, and this is fine. We get a job done. We reproduce the image. But what if we reproduce this image by the concept of mapping a lot of letters and codes on the canvas with different shades that we analyze from the original image? So what is different? So doing this are layers and layers where we came to a stop where we just couldn't add any more things on it. For example, this place here, or you can add white color on it, but I don't know how it's going to help. But with this, let's say, okay, now I want to see my face more. Or I don't like the letters. I could easily change the data input to something else. For example, like this. So, and I did this with just a second of time, like, a snap of fingers. I just changed the parameters and input to produce the same task, but, with a bit of a different logic behind it. Instead of adding layers and layers of tone on it, I analyze the pictures and I tell the computers, okay, look, don't put layers on it. I want you to just scale according to the shades. And the computer did it and it generated this for me. So to put it simply, what was that? What was that process just now? It was the act of defining. So define here, I have an image, I have data. So the data, be it a letter or the zero, and I generate. So that's what happened just now. And of course, that won't bring us to the associative logic. But first, I want to tell you or to make an interim summary about, how we actually approach design. So in the most traditional way or conventional way of how it was done, usually we define the parameters, the parameters here, don't get confused. It doesn't necessarily means computer codes or whatever. That, for example, you get a piece of land, how big or how small, how long on the parameters of it is the parameters. Those are the parameters. You want your house to be red instead of white. You want your house to be 3 stories instead of 2. Those are parameters. So we define the parameters. And then we generate design options. And then we check in our office or with our colleagues, with our clients, we explore. And then the comments come back and we adjust, we adjust, notice, we adjust on this stage over here, which is after the generated design, we explore on this part here. And what is the difference? I'm going to tell you later. And after adjust, we go ahead to produce. So you see the house in the end. That's not a problem if the client is happy. But what if the client is unhappy about that? So we talk about that on the next part. But to sum it up, this is what happens to additive logic. We define, we generate design, and we explore the design, and we adjust the design, and we produce. Seems fine. That's what everybody do. But maybe we have other way. So what if we generate we start with the same thing, because you couldn't drink water without having water, so you define and you generate, do whatever you need to do. But the difference comes in the exploration stage where you can take in a lot more input. And I suddenly decide, okay, look, I just don't like this, it's just, what are those white lines, in between? It seems like I'm disappearing. I don't like that. And Mr. Designer, can you do something about it? Oh yeah, of course, let us redefine with data and let us regenerate. Simple as it sounds, but how has it been done? So let's look back at our additive logic here. So there's one thing that I want to explain to you guys. Additive logic and the next logic I'm talking about, their relationship, they are not going against each other. They don't hate each other. In fact, the next logic that I'm going to talk about is a development of this additive logic. So we take a step back. Let us not produce it first, yeah? And then let us not adjust anything that comes out from the generated design. Instead, what do? We feed the commands back to our original definition. Yeah. So I don't like the letters on my face. So I want them to be all just zero, Mr. Designer. I want to be all zero. I don't want letters on my face. They don't look nice. So fine. You don't want letters? I give it zero. But with the brush, you can't do it because you can't tell the brush, instead of doing white, you do it black this time because it's painted. The layers are done and they might not even be visible anymore, And, through this loop here, we then go to produce. We find a suitable image that we want and we go ahead to produce in the end. And what is the most precious thing about this produce part here is that if we generate things with this kind of feedback loop, we could actually feed data back to the definition as well. And let me give you a very good example. It's in your hand. It's in the hand of most of the people nowadays. So by looking at the Apple iPhone, for 13 years, they are making iPhone, So what is the difference between generation and generation of iPhone? Is that it is literally generation that is better than the previous generation. So in other words, one previous generation, they will take the next generation's data and come back and make the next one. And so goes the loop on and on and on and on till, whenever you want to stop it. It doesn't matter. So that is the concept of, establishing this feedback loop. And this is associative logic is about. Yeah. So we call them iteration. So all of those iPhones, every generation of it, they are actually the iteration that is created by Apple company. Yeah, at iterations of good phone, so that the next generation could be a better phone than the previous generation. That was what all the ideas about. And what is iteration in details? Now I'm going to share to you about my experience of working in Germany, Cologne, how we work. And I think this will help relate you from a phone to architecture. So what is iteration? So this is the firm that I was working with. It's called Kister Scheidauer Gross Architekten und Stadtplaner GmbH. It's a long name, it's German. In short, it's called KSG Architekten. So what Architekten, you can guess, architects, Stadtplaner, urban planner. Stadt is urban in German. And the office is located in Cologne. And that's where I work. And these two, if you can see that red dot on my screen right now, that's where our office is. It's actually, we are occupying this whole row. And this is River Rhine, that famous River Rhine. And here is a little bit, 15 minutes walking away is the famous Cologne Cathedral. Okay, so that's where the office is. And that's how the office looked like. They were my colleagues, nice people, nice lunch always. And that's where I sit in all this. That's not important. So that's where I sat, and with my colleague Melanie, Ation, and Matthias, four of us formed the competition team of this company there. And we of course work very hard because we have a German boss, you know. And what we do every day, and what my work was exactly, to make generation and generation of models. So that was a school project, you know, that's a massing model of it. I guess at this point, a lot of UCTS students would know already what a massing model is. So that's a massing model, and the white color, a little yellowish, you know, is the school. And the parameters that we got was that you have to design around the school, and you have to add things on it or take things out, but you have to design around the school. So that's you know, the logic behind each of the iteration frame here. So we make, or I made, the massing after massing, massing after massing. Another project is a laboratory in a city called Braunschweig, is in the center of Germany. That was also a good project that we did. It's laboratory, and the parameters that we got was to use up the maximum plot of land to stay efficient. So that's where we got, and then we try to implant this central core concept over the time with different parameters. So it's the same. We make iteration after iteration, iteration after iteration, a generation different than the previous generation. And that was a project in, what is the city called again? It was a very small city. The city is called, I don't know, for some reason, my mind went into a blank right now. I just don't remember the name of the city, but you know, the mission is to design a Rathaus. A Rathaus is a municipality council building. That's where all the council people sit in. It's a government office, but anyway. So that's located in the center of the town, and same task, iteration after iteration. But it's just a bit shame that I didn't get to document fully on this project because I was very busy and overwhelmed with the work, so you didn't get to see the final of it. Yeah, this was when we were not that busy, and we still get to do a model per night. Yeah, so I have time to take a picture on the second morning, but when we don't, so I don't take pictures. So these are iteration, and so on and so forth. But you know, why am I showing you this? Why do we iterate our design? For what? I must tell you a bit on how the environment of architecture industry is in Germany. It's a competition-based, you can call it market, where all the architects, there's no private and public architects. So there, of course, we do not have that too, but you know, all the design, as long as it is connected by an urban street, it has to be made public. Yeah. So that means, apart from design a building that's for your own interest or your own house, as long as it is more than one party's interest, you have to go online, you have to go for a competition. And that is why we iterate our design. So this is a project that we won in Cologne, first prize, directly right opposite the cathedral. That is why you don't see cathedral, because it's opposite it. So I'm sorry. That is a mixed development, or so-called, you know, one of the very typical urban typology in Germany, where you have huge block like this that contains a lot of units in there. And of course, the interest is more than one people. And we went for a competition, and my team, of course, headed by Mr. Kister, which is our boss. And our teammate, Matthias, Artyom, and Melanie, we won this competition in January 2019. And before we go there, that was the same process that we have to go through, you know. And I cannot show you the messing of what we've done because we actually won this project and everything become a bit confidential. So that was the news that came out from their council website to make it public and announced. And for each of this competition, they actually have to form a jury board that is consists of different people from different across all kind of disciplines. That means not only architects, although it will be headed by an architect, but it's always you know, inviting judge or lawyers, and most importantly the grassroots, you know, the people that do all kind of jobs to come in. But of course you have to be a cologner to judge, hey, do you want this piece of thing standing on your street, you know, tomorrow? So that's why we have to choose, you know, we have to find our best solution. There's no private clients for us. If you call Cologne State Office, hey, please give us some parameters, they will say, if you can't do it, then you are not the architects that we want, you know? So that's why we iterate our design to see each of those different messing, you know, what are the arguments that we get to build from it. And so as my boss call it, Mr. Kisser call it, an urban argument, we literally make a lot of iteration and iteration. And yeah, so that was how it was done. 8-0 print out every night, every evening, you know. And you know what we get on the second morning when he came, you know. Yeah, that's the thing. And the second project that we won is a city right next to it. Is Düsseldorf. Is a competition. Wohnen means living. Wohnen here means living. Is next at Sonnenpark is a park in this city called Düsseldorf, and it's also a first prize. And we went through the same process, and the state has to publish it, you know, with the name of our firm here. Oh yeah, they won it. They got the first prize, and now what you have to say and all kind of things. Yeah, then that is the final model. Yeah, the kind of you see those pins on it, and that was a better version of it. It was completely destroyed, yeah, before it came to that stage. And of course we went through process and process again. So that was what the associative logic was about. You know, you go through a process of designing, you define the parameters with your own, you generate the design option, and then you explore that. And in this case, the producer don't actually apply in the previous project that I showed, but you know, the produce here is more of the messy model that we did. And you kind of give all kind of feedback back to the original definition of this design, and we run iteration for it. And why iteration is important. And you know, that was explained. I hope, you know, that you guys got me correctly, is to include opinions. It's just as simple as it is, you know, to include a lot of opinions from a lot of people, to be democratic, you know, to listen and to be an architect of everyone, no matter you agree or not. But that was the purpose of us, you know, to iterate our design. And for the next thing, for the next part of the talk, you know, I would like to introduce you to a tool. So interestingly, what I showed you earlier on was all manually done. I cut the models, you know, with hands and all that. But of course, you know, to make our time interesting, we have tools and digital tools that has been invented to do such kind of iteration process. And next, I would like to tell you my experience from DIA, Dessau International Architects, in the university, which is right next to Bauhaus. And all my fellows DIAs, colleagues, Now is the time. Oh, sorry, for a bit of typo here. I left out en, but it's applied science. So for a lot of my fellow DIAs, ex-DIAs, please, if you have something to say, just raise your hand. I don't mind got interrupted. So yeah, that's where I want to show my German university experience with you. And that was where my studio was. This is my studio, and this is where the Bauhaus building is. We're right next to it. And that's where I work and, work my guts out. So right now, I would like to switch to this program called Rhinoceros. And don't worry about that. I'm not trying to teach or show you more about Rhino today because it is all about the logic. But in order to explain the logic, I want to show you how the digital tool could do this much more efficiently. Those things I did with my hand. Okay. So, so how do I switch my share? Here. All right. So some of you might know this tool and some of you don't. But for those of you who don't worry about that. As I say, it is not about the program, but what I want to show you is how the associative logic could be digitalized. And Grasshopper is not the only tool that can do this, although it is the hottest program on the market that is available to do this. Yeah. So for those of you who know, I use Galapagos. For those of you who don't know, I use a so-called evolutionary genetic computational engine, which is this magenta thing, is a function in this plugin to calculate for me what is the most optimized solution of the parameters that I gave. So on my screen here, you see the plan view of one of the projects that I did when I was in the school. In fact, that was my first parametric project. And the site is located in Portugal, but then I won't go deep into the project and what the project is about. I want to show you the logic behind what I've done here. So this is the top view of this project, and this is the perspective view of this project. And this is one of the iteration option that I've chosen. So how this model was built, and it is actually a 3D model. And when I rotate this, you can see it is a 3D model. Yeah, it is not a dummy snapshot. And this blue thing is the water. So I want to float the entire village on a submerged, it is a submerged village. And the concept was to float the village kind of romantically again back to the surface of the water. You could ask me later more about this if you don't understand what I said here. But in short, I want to create this red chalet with this green platform. And I need to know what are the best configuration. And there are 192 units in there. 192 units means the blue and red add together. Imagine that all of these, both red and green, they have a points, so there are 193 points in there. So how do I find out what is the most optimized solution for me? So I created the logic on this canvas here. So firstly, I need to kind of digitalize the entire environment. So what I did, I took the entire terrain, which was provided by David Alfonso, a scholar from Portugal, which I was working with. He made a detailed survey analysis of this entire terrain. So I got these digital data from him. But of course, it's just a 3D model that has nothing. And I have to analyze it with my own way. Yeah. So I made this kind of logic out. I created this kind of numerical parameters with on my own term. And don't worry about these little gray black stripe things. They are just, you know, a feature of this program. And if you know this program, you know what that is. For those who don't know, it doesn't matter. As I say, it's not about the program. So what you need to know is that I have 4 big parameters here, which is the blue one is the water, and the green one is the submerged part of this village. So if I just quickly do this to show you what I mean by the water level. Okay, so the dam, right? The dam, sometimes the water run dry and sometimes the water run high. So I need to parameterize the water level in that. And if you can see now on the screen, sorry, my computer is just too slow for this, but you see the water is subsiding. Yeah. So that was the kind of parameters that I have to work with, you know. Of course, a good task from my professor, Lizzie Venner. And that was the first project I did with her. And, you know, I did that. And of course, I have to also take into consideration of this area here, where you know, this area here, which is a submerged terrain, I need to know, and I need to parameterize it. And I need to know the jungles, the virgin jungles that's still available around it. And I also gave it parameters. And nevertheless, you know, the submerged village, which is what you currently see down here, all these gray little balls. I know it's not very visible, but it's not important. So with the parameters of environment, I went ahead to came out with algorithm, you know, that give me essentially where the position of each chalet will be and where the open platform will be. The chalet are demarcated, denotated in red, and green are the open platform. And I need to know their positions respectively. And I did so, of course, with parameters. We don't talk about that. It's fine. You just need to know that I want to know where are the red, where are the green. And eventually from those positions, I generate the chalet I want with the design I made and the open platform. And what is the most important thing in the end is that I need to know, you know, the relationship between these two guys here. So the ratio of the floor area, the chalet vs open platform over here. And I want it to be half-half, you know, I don't want it to be one thing is more than the other, or maybe it's good that one thing is more than the other, but I need to see, you know, what is the advantage. So with this engine, it makes that associative logic that I showed you just now possible. So with these parameters, and you see these numbers, you know, these are the parameters that I was talking about, you know. So I animate them. I ask this engine, hi, it's called Galapagos, Mr. Galapagos, please give me hundreds of options, if not more, you know. Let me know what you think. So did what the Mr. Galapagos did. Let me show you. Because it's very heavy to computate and run the video in the same time. So I did that already for you to show you. So this is what the screen looked like. You guys actually see this, right? Yeah, okay, cool. Wait a minute. Okay. So this is this dialog box here is how it looks like when that thing run. It doesn't matter. It's not about the program. So so now this is how it looks like. So you can see that, you know, of course, I told Galapagos, you know, what are the parameters, what you need to calculate, the size of the chalet, the maximum and minimum size of it, and, roughly, you know, how many rotation you have to make, you know, and with that, it calculates and it gives me, I think I have here over 60 options for my choice. And these numbers here are the numbers that I meant just now with this ratio here. So it gives you 44 times more. So this 44 here means the green area is 44 times bigger than the red area, you know? So that's what every numbers means in every of these iteration. And so from there, I was presented literally with, 50 or 60s over options of it. And of course, I went on to the next stage, which I'm not going to show, but you get a point here, to iterate with the tool, with this kind of calculating engine, a computational tool. And let us go back to our slide. Where is my slide? Oh, yeah. Okay, cool. Yeah, so that was what I did. And that was the tool in Dia, which I used to make my project with. And that was about associative logic and generative design that I had on my first try. But what is this all about? Think for a next stage, If we could reiterate our design, yeah, we could do that with the hand, but what is the difference with the hand and with the computer? What is the difference? Why do I have to do it with computer? Why I can do it with hand? Maybe I prefer hand. Of course, you can do it with hand. That's totally fine. It's not a problem. But I just want to tell you, I see a genesis of a future here. So next, I will tell you another company that I've worked with when I was in Germany, 2 years with them, CEC, Solution GmbH. It was, it has 2 offices. It was one of them in Dessau, another one is in Munich. And I work with the Dessau, which is where the boss is, So that was it. The beautiful painting when you get into the door, CEC project. And from this iteration, actually, we have a purpose behind it, why we do it in computer. And that is to turn all this process into data. So all of those things that I show you just now with Grasshopper, with that tool, with that program that I was using, it was actually for, to generate data, no matter the parameters of it or the process of modifying things is to generate data. So when I was with them, I was sent to a training program. It was called Passive House. Passive House conference. And from there, I got a glimpse. I think I chose this to show you guys because I think it's a very compact and very good way to show what I mean with what we use with these data. Yeah. So that was one of the factories that we visit when we were in a this conference. So it was like a house building company where you just go to them and you tell them, I want a house, and it designs for you and it builds for you. It's kind of like a design and build. So that was the program that I used. Don't get confused. This is not your BIM program, although it looks a lot like it, but it's totally not. It's a CAM software, and it stands for Computer Aided Manufacturing Program. So what this does is that it computes all the size of the beam, the purlins, and the columns, and all those stuff, they turn them into numerical data. And next, they take it to the factory just behind the office. And they feed it through this pretty amazing beast, like this you can see here. Sorry guys, I was really amazed by this, what this machine could do when I was there. I took this picture, yeah. So, basically you feed, oh, sorry, the picture is not so good. The raw woods, you kind of get it from this side of the factories, and the machine is right here. And they feed it through this machine, and all you have to do is wait. Now loading, and then it came out with a piece of cutted wood. And all of the entire process is a one-man show. This guy has to basically just stand in front of a computer and, you know, click a button. The feeded wood will go into the machine and came out. In the end, it does all kind of millings, you know. All of this is done by him. And he told us he did this entire set, 2 or 3 sets a day. So in other sense, one man built your roof structures in 3.5 days time, you know. So he was chill and talking and, you know, living a good life. The computer did his job. And that was why the data are important to us, guys, you know. During this design process, we don't just design, you know, we generate data, you know. And yeah, so that was the office. It was completely printed, yeah. And you can see we can stand on it, take pictures, and it didn't fall, it didn't crumble. And that was a printed house. It was in Austria, by the way, I'm sorry. This factory was in Austria, in Innsbruck, is a border city between Germany and Austria. And it's located very near to Alps, covered with snow, basically, all year round. And yeah, that was where the factory is. And that was where I got impressed by this using of data. And don't worry, guys, we are approaching the end. So with all these talks, what is it all about, right? We talk about associative logic and generative design, and all of it is to generate datas and datas and datas. And what is it all about, this associative logic? Well, in my opinion, associative logic is the logic of generative design. And generate design with data, one way or the other. If you don't like Grasshopper, go with others, you know, be free. Is genesis of our future built environment, when especially we talk about Asian context, when we got cities got denser and denser, more and more things are digitalized and could be digitalized and datafied. And I think now I see that generate design with data is the genesis of a future built environment. And of course, I don't mean that in that case, designer will die. And it is totally opposite. And this is a time, it's also a genesis of an era of evolution of all architects and architectural designer. And with that, I end my talk today. Thank you very much.